Okay, so for number one, the sine bar, of course, it's called a sine bar because it uses the sine. The definition of sine is sine of an angle is equal to the opposite side of the hypotenuse. In this case, we have the angle, which is at 28 degrees, 20 minutes. That's going to equal the opposite side is x, and the hypotenuse is 10. We are looking for a side. When we're looking for a side, we make it into a proportion and we cross multiply and divide. So this is going to be the sine of 28 degrees, 20 minutes times 10. So there's a sine, 28 degrees, 20 minutes, times 10. Technically it's divided by 1, but we don't have to do that. So you're at 4.746 inches. How many of you had that? You might have done a cosine instead of sine. Oh, well, shouldn't be a rounding error. It might have been the way you tried to enter the. You might have done sine of 28.2 degrees instead of sine of 28.20. Oh, that'll do it. Because 0.333 is going to be rounded off. So that'll make that slight difference. Okay, now number 2 here. We need to find our triangle. We're looking at this triangle right here. We know this side is the 8 inches. It's this side here we need to find. That side is going to be half of the difference between our two diameters. So 2.850 minus 0.350 is 2.500. That's the difference in diameters. We need to divide that by 2. 1.250. So this here is 1.250. And this is the angle we're looking for. What sides do we have there? Opposite and adjacent, which is which trig function? Tangent. Tangent of an angle is equal to opposite over adjacent. We fill in what we know. We don't know the angle, but we know that the opposite side is the 1.25 and the adjacent is the 8. Are we looking for a side or an angle? We're looking for an angle, and when we're looking for an angle, we do inverse trig function. This is a tangent, so we're going to do an inverse tangent. So the tangent and the inverse tangent cancel out. That gives us theta. We have to do the inverse tangent, so second tangent. In our parentheses, we go 1.25 divided by 8, close the parentheses, 8.88 degrees. Anybody have that one? Number 3. In number 3, we've got the 50 millimeters from here to here. We just need to find the total height from here to the top of the round stock, and we'll subtract it x. Well, to get this total height here, we have the 10 millimeters here. We need to go from the base of the V to the center of the ball. That's the one we're going to have to use trig to find. But then we also know from the center of the round stock up is 30 millimeters. So I just need to find that purple dimension in there. Well, let's finish out that purple triangle. We draw a radius out to that tangent. Of course, that forms a right angle. It's that triangle that we're concerned with. Do we know any of the sides of that triangle? Yes, we know this one is how much? 30 millimeters, because it was a radius of that circle. Do we know any angles? This isn't 70, it's 35. Very good. Because that cuts the angle in half when it goes out through there. Now, the dimension we really want to find is this one right here. I'm going to call that C because it's across from the right angle. That is the hypotenuse. What's the 30? Opposite. Of course, now that's going to be sine. Opposite over hypotenuse is correct. Do we know the angle? Yes, we put in 35 there. Do we know the opposite side? Yes, that's 30. We're looking for the hypotenuse. Are we looking for a side or an angle? Looking for a side. So I make it a proportion, and we'll cross multiply. 1 times 30 is 30, divided by the sine of 35. 52.30. So that's 52.30 here. So what that does, that gives us 10 plus 30, 10 plus 30 plus 52, which gives us 92.30. We subtract the 50 millimeters here, gives us 42.30 that sticks out. That's X. What do you think? So in a problem like this, the types of problems we're going to start looking at today, and we'll continue looking at them tomorrow, are problems where the right triangle may not be that apparent, and or we might have to use a couple of different triangles to get to where we need to go. So what we need to find here, what we're looking for is this angle X over here, which is the angle between the vertical and the slanted surface. Now, we need to look for possible right triangles. One thing I'm going to tell you is this surface here, the center of that circle, and this surface here are lined up down through there. We see that circular portion, and anytime we see that circular portion, we're looking for a right angle where? Whenever we see a circular part, we're looking for right angles where a radius meets a tangent. So the radius of that meets that tangent, that makes a right angle. Now we need to turn that into a right triangle of some sort. I'm going to connect it like that. The center of that circle down to there makes a right triangle there. What do we know about that right triangle? If I draw a little bit bigger here, here's our right angle. Do we know any of the sides? Now this is 42 millimeters here. Do we know anything else? No, we don't. So let's keep looking. Can we make any other right triangles? Well, the other technique we have for right triangles is vertical and horizontal dimensions. I need to use it to find more sides of this triangle here. If I drop this straight down, that's a vertical. This is a horizontal. That's a right angle there. And I can find that by subtracting the 42 and the 120 down here, which gives this, what, 78 millimeters? But I can also find this. I've got 38, 32. This is still a radius of the circle. That's 42. So that's what, 70, 112. It would help if I'd given you this dimension over here, which, let's just make that 210 millimeters. Forgot to fill that one in. So that's going to be 210 minus the 112. You guys see where the 112 came from, right? Those three. This here is just what's left over. That is what, 98 millimeters? So now that we have that triangle, there's two things we're going to find from it. One, we're going to find this side so we know that side of the other triangle. How do we find that side? A squared plus B squared equals C squared, right? So square root of 78 squared plus 98 squared, 125.252. The other thing we're going to find is this angle here. From that angle, we have the opposite and the adjacent sides, which is tangent. So do we know the angle? Nope, that's what we're looking for. We have the opposite side's 98 and the adjacent is 78. We are looking for the angle, so we use inverse. We're using tangent, so we use inverse tangent. So the angle is the inverse tangent of 98 over 78, otherwise known as 51.48 degrees. You might be wondering why that angle is important. Well, because that angle is right there. Now in this other triangle, I have two of the sides. Once I have two of the sides, I can find this angle, which will be this one. And I know those three angles have to add up to 90, right? So I'm going to find this angle here. This is the opposite side. The 125 is now the hypotenuse. Opposite and hypotenuse make sine, right? So we fill in sine of that angle is the opposite of 42 over the hypotenuse of 125.252. So we're looking for an angle again, so we're going to do an inverse trig. That's a sine, so we do an inverse sine. So theta is the inverse sine of 42 over 125.252. So second sine of 42 divided by 125.252. 19.59 degrees. So we add those up. 19.59 and 51.48, which gives us 71.07 degrees. We subtract that from 90, gives us 18.93 degrees. So X is 18.93 degrees. See how simple those can be? We will talk more about these tomorrow. For right now, in your packet, page 368 through 371, there are several problems similar to this for you guys to play with in the next